Hello all, myself Chanil Popat. Let us discuss new chapter, pile foundation today. In this picture, you can see something like it is something being inserted in the soil. That is none other than pile. The building will be on these piles and it is a pile foundation. Let us begin understanding of the concepts of pile foundation. What are the necessities of pile foundation? Now, the load of the superstructure is heavy and distribution is uneven. Why you need to use pile foundation or insert a pile in a soil? So, first reason is that the load of superstructure is heavy. So, if your superstructure is heavy in load, then you should opt for this. The topsoil has poor bearing capacity. So the top layer of the soil is poor in bearing capacity. Then you have to go deeper in the soil to have some strength, right? For the third point, the subsoil water is high, so that pumping of water, pumping out of the water is not working or is not economical. Then you should have pile foundations. There is large fluctuation in subsoil water level. If every year the subsoil water level, or we can say groundwater table, is going high, low, if it is fluctuating every year, then you should opt pile foundations. Where timbering to the trenches is difficult and costly. In the case of timbering the trenches, if it is difficult and costly, you should opt pile foundation. The structure is situated on the seashore or riverbed. You must have seen platforms, or you must have seen on the beaches there are some floors constructed, right? Those floors are constructed on pile foundation. So the structure is situated on the seashore or riverbed. You must opt for pile foundations. If you remember, any building of Mumbai, generally in high-rise buildings of Mumbai, uh, they use pile foundations frequently. Canal or deep drainage lines exist near the foundation. If your foundation is going besides the wet section, or we can say canal or deep drainage lines, you should opt for pile foundation because the soil nearby that will be softer and it will be having lesser bearing capacity. The topsoil is of expansive nature. So the topsoil, if it is an expansive nature, you should opt pile foundation so that the building will be safe. And the last point is piles are used for the foundations of transmission towers, offshore platforms which are subjected to uplift forces. So piles are also useful and important against uplift forces. So the uh, down if the downward soil is taking you upwards or taking your structure upwards, then it is an uplift pressure or uplift force. In this case, you should also opt pile foundation. Moving further to classification of piles. So piles are classified in various ways. Let us begin first way based on method of load transfer. So how the pile are transferring the load, it will classify the soil, classify the piles. End bearing pile and friction piles. These are basic two types against its load transfer mechanism. So let us begin understanding that. Here you can see an image. In this image you can see first item which is end bearing pile and second one is friction pile. So the bottom end of the pile rests on hard strata, then it is a end bearing pile. Here in this image you can see the bottom end is resting on a hard strata, although the above portion are a weak soil. In the case of friction pile, when loose soil expands to a great depth, bottom end of the pile does not reach up to hard strata. So, if there is no hard strata available in the bottom or very deep in the bottom, then you should go for friction piles. Load is transferred at the tip of the pile. In case of end bearing pile, the name only suggests that end bearing. So bearing is done by end or tip of the pile, where in case of friction pile, load is transferred to the soil surrounding the pile by friction between soil and the pile material. So between the soil and pile material there is friction, and these pile works on that friction. It is only suitable when hard strata is available. So in case of end bearing pile you require a hard strata, but in case of friction pile you don't need a hard strata, you need a loose soil. Pile act as a column if it is a end bearing pile, where in case of friction pile will not act as a column. End bearing piles are normally driven in vertical direction. So here you can see this pile is in a vertical direction, but in case of friction piles it is not necessary they are vertical, they may be inclined direction. Dimensions of the pile are determined from load on pile and its material. So dimensions, I mean diameter and the length of the pile, are determined by total load on the pile as well as the material in the pile. Where in case of friction pile, dimensions are determined from load as well as roughness of the pile surface. So here we are talking about friction pile. So roughness will play a big role. The length of the pile must be equal to the depth of hard strata from ground surface. So the length of the pile also must be equal. Here, in case of friction pile, the length of the pile must be reduced by increasing the diameter of the pile or by increasing roughness of the surface. So, as it is working on a friction, so you need to increase the diameter and decrease the length. So, you can keep the volume similar to that and it will be an economical section. So, that's it for end bearing pile and friction pile. Moving further, classification of piles by based on their function or use. So first pile is compaction pile. It is driven and it works as compaction pile. As you put it or insert it in the soil nearby that or soil in between those piles will get compacted. That is why it is known as compaction piles. Tension piles. Tension pile is working in tension only. Here in this image, you can see a transmission tower like design, and these piles are working in tension. If the pile is getting stressed or stretched from both the sides, it is a tension pile. Anchor pile. Generally, for retaining wall rehabilitation, anchor piles are used, or you can see, and it works as an anchor. Here you can see here a retaining wall, and this is an anchor pile or tie-back anchor. It will do what? It will support the retaining wall or any structure. Fender pile. Fender piles are generally used on river sides or ocean, right? Or we can say seashores. Here, these fender piles, you can see that on these fender piles, the platforms or bridges are constructed, but of small caliber, not for a large calibers. Better pile. Here, better pile can be seen as an inclined pile. You can see an inclined pile here. These inclined one is a better pile. It is generally used as a supporting structure of an anchor pile. Sheet piles. Generally, caverns and all seashore structures are constructed with the help of sheet piles. Here, these are, you can see a pultruded sheet. They are inserted in the soil and the water inside that is pumped out. That is how it works as a sheet pile. Classification of piles based on materials and composition. Now, first is concrete pile. So, based on material and composition means if the pile is made up of concrete, then it is called as concrete pile. Here you can see a square sections or column sections kind of things as a concrete pile. But here it look like a column, but it goes inside. It is driven inside by a crane, and this is how it works. Now it is made of concrete, but there are two types in concrete also. first precast and second one is cast in situ. So if you are casting the piles at site, on site, that is a cast in situ pile. But if it is precast, cast at other place and driven at your required location, then it is a concrete pile, or we can say precast concrete pile. So these are different piles in concrete piles, but you have to choose a perfect driving method or perfect inserting method of pile also. Steel pile. These are made up of steel. That is why it is known as steel pile. They are also driven in the soil by a heavy hydraulic jack. Timber pile. Here you can see piles made up of timber and they are inserted. They are generally inserted in timber structures or timbered structures in earthquake prone regions. Generally, in case of where earthquakes are very frequent, like in case of Japan, they are using timber piles. Composite pile. Composite pile is very easy and very emerging because they are made up of two materials. Here you can see two materials as concrete and timber. So a pile is of timber but it is layered by concrete. So it will get strength for concrete as well as timber both. And sand pile. Sand piles are generally made up of sand but they are inserted like a cast in situ structure, not a precast one. Let us move to next classification, which is based on method of installation. So method of installation is also important in piles. Here you can see something is inserting pile, right? So different methods are there to insert piles. According to that, these are different piles. Here first type is driven pile, which is driven, which is only inserted in the soil. Second one is driven and cast in situ piles. So they are driven also. For an example, a hollow steel pipe is driven and then concreting is done. So they are driven and cast in situ both. Bored and cast in situ piles. Sometimes piles are bored. Like if you are doing auger boring or boring, that is how pile is driven in the soil. As well as it is a mixture of bored and cast in situ piles. You have to cast upper section although you are boring that. Screw piles. It will act like a screw in the soil. These are known as screw piles and jagged piles. Jagged piles are what? They are inserted in the soil by pressure. These are jagged piles. So these are due to method of different installation techniques, or we can say methods. So that's it. In this lecture, we will understand more concepts of pile foundation in next video. Thank you.